Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in MBSS 222 as the math tutor. And my job is to help students in their math problems and math difficulties as students here at Walter State. And this is the second part of factoring in a multiple section uh, group of lessons on factoring. And this is factoring by grouping. The first part was factoring out the greatest common factor. And this is just an extension of that greatest common factor um, idea that we use. And as you see this first one, that's all we're going to do on this very first problem here of 2xa plus 3a is we're going to take this common factor of a and we're going to factor that common factor out. And since that's the common factor, we're going to bring it out front. Then we're going to factor out 2x plus 3. And as we do this lesson, we're assuming that you know how to factor out that common factor. And if you're not comfortable with the greatest common factor, you can go back and watch the part 1 of this factoring set of lessons. And notice again we brought out that common factor of a. A times 2x gives me that 2xa back. A times 3 would give me 3a if I multiplied it back. Now, notice that we can do that because that a is common. We can also do that if that a is common and not just a single variable like this a is. We can do that if it is a group of items like in problem number 2. This a plus 5 is a group, but it is still a common factor. It is a common group of items grouped together here, multiplied with the 2x. The a plus 5 is multiplied with 3. That makes it a factor. Therefore, it is a common factor. And because it's common to both terms, here and here, we can bring it out as the common factor and then write what's left, which is 2x plus 3, because when I take out the a plus 5 as the factor, what's left is the 2x. Bring down the 2x. When I take out the a plus 3, the factor that's left is the 3, so I have plus 3. Notice that this gives me something that's in factored form. Now I have two things that are multiplied that give me back what I started with. And it's this process that we're going to use to factor things that have 4 terms. When we have things that have 3 terms, there are other ways that we factor them. Things with 2 terms, there's other ways that we factor them. But the first thing that we're going to do is we're going to look for the greatest common factor all the way through. That is the first step in factoring, no matter what we do. As we look at this, anything with 4 terms, we have to use the factoring by grouping. That's the method that's required. And as we look at this, what we want to do is we want to create a problem that looks like this previous one, where it has a common set of factors, that a plus 5. And if it's going to work, it works very smoothly and very almost like it was meant to do that, because it was. And if it doesn't work, then it's what we call prime or not factorable. Okay? And in this case, what we're going to do is we're going to look at just the first 2 terms, here and here. we're going to ignore the last two terms. And when you come in to work, I'll often just cover those up. Actually, I think I'm going to do that here. I'm going to just cover those up. Take a sheet of paper and not even look at them. We're just looking at those first two terms. I think I'm going to come in just a little bit on these. Okay, we're going to look at those, and we want to see what's common to those first two terms. Well, they don't share a number. All they share is an x. So we're going to bring out and factor out that common x. If I take one x out here, that leaves me 2 here, because remember we have to add exponents. 2 plus 1 to give me 3. Plus, if I take out 1 here, that leaves me 1 here. Well, wait a minute, I goofed. And I do that sometimes. I didn't take out the greatest common factor, did I? And nobody's perfect, but that's the wonderful thing about pencils. We don't take out a common factor, we take out the greatest common factor. And our greatest common factor would be x squared. Because I can take out 2 and leave 1 there. And if I take out 2 here, that leaves none. And remember, 1 is a factor of everything. And remember if you've watched the first video or the first part of factoring, you'll remember that I said 1 as a factor of everything comes into play. And here's one place where that works. So we have x squared times 1 to give me back x squared, and x squared times x to give me back x to the third. And it's that combination that allows us to factor that. And that gives us back those first two terms. Now I'm going to cover up those first two terms for a minute, and I'm going to look at these last two terms. What do the last two terms share in common? They share a 3. So I factor out the 3. 3 goes into 3 one time and leaves just that x. And 3 goes into itself one time and leaves the 1. Because 3 times x would multiply back to give me 3x. And 3 times 1 multiplies back to give me 3. So I factored out both the first two terms and the last two terms. Now, I'm not going to cover up every problem. I just wanted to do those two so you can kind of get a feel of how we're just looking at the first two and then just looking at the last two. One of the rules that we also want to remember is whatever sign is between the two numbers is the sign that we bring down in between them. In this case, that was a positive. We'll look at what happens if it's a negative in some of the later problems. But now, what do we see? We see that we have that common factor of x plus 1. So we want to write down the common factor of x plus 1, and then what do we have left? We have left x squared plus 3. And we have factored this out. Now, this is the answer, but let's do a quick check, because that's the nice thing about factoring, is it can be checked by multiplying it back through, and if we multiply it back through, we should get what we started with. So I'm going to multiply it back through using our FOIL method. Our first, x times x squared, which gives me x to the third. Our outside, which would be 3 times x, which would be 3x. Our inside, 1 times x squared, 1x squared. And our last, 1 times 3, which is plus 3. And if I write that in descending order, basically if I write that with the x squared and then the x, it matches up exactly with what I started with. Because I wrote my items down in a slightly different order than what we started with, I get a slightly different order here, but it really is equivalent to what I started with. Okay, let's look at a couple more examples. On this one, again, let's look and see what the common factor for the first two terms is, and that would be an x. And when we take the x out of 3x squared, we'll be left with 3x. Factor out the x out of xy, and we're left with y. Because if I multiply those back, I'll get x times 3x is 3x squared. X times y is xy. Here's the example where there is a minus in front of here. This means we're going to be factoring out a negative. Whatever sign is here is the sign that we bring down. Then we're going to look and see that these have what in common. Well, in this case, they don't share a variable, but they do share the number 4. 4 goes into both 4 and 12. But in this case, we're going to factor out as if it were a negative 4. Negative 4 goes into negative 12 and leaves me a positive 3 with the x. Notice what this is going to do to my sign. A negative divided by a negative gives me a positive y. When I bring out this negative, it's going to make this term a positive and this term the opposite of what this one is. And since that's a negative, that's going to make that a positive, because negative 4 times a positive y gives me a negative 4y that multiplies back to be what I need it to be. Here, a negative 4 times a positive 3x gives me back the negative 12x that I need it to be here. So it makes and forces the algebra to work. How do we do that? Because when we bring down a negative, that changes and makes them the opposite signs of what they need to be, because of the way that our negatives and positives multiply. But notice too that that now makes this and this match up. And again, you're not going to be circling those 3x plus y's. I'm doing that for emphasis so that you can see that. And we can write down the common term, 3x plus y, and the part that's left, the x and the minus 4. Okay, let's look at another example, looking at the first two terms and looking at the last two terms. The first two terms have in common a 3 and an x. 3 goes into 6 2 times and an x left over. 3 goes into 15 5 times and it takes the x out. Common to the last two terms, the plus sign brings the plus sign down. Common to these two terms is a 2. 2 goes into 4 2 times, leaves the x. 2 goes into 10 5 times, leaves the x. The 2x plus 5 is the common term. Then we're left with 2x plus 5. And write down the parts that are left in front of those, which would be 3x plus 2. Now, some of your teachers may be writing the 3x plus 2 down first and then the 2x plus 5. There's no difference in that. It makes absolutely no difference whatsoever. And we could multiply back these to check, and that would work, and you can do that on your own. Let's look at the next example. 8x squared plus 2x minus 12 minus 3. And again, looking to the first two terms to determine what's common. What's common to those is a 2x. And to get what's common there, we have a 2x. 2x goes into 8x squared. 2 goes into 8 4 times. Take out one of the x's. And then 2x goes into itself and leaves a 1. What goes into both the 12 and the 3 would be 3, but we have to keep that negative sign there because it brings down. And then negative 3 goes into negative 12 and leaves me a positive 4x. a negative 3 into a negative 3. A negative divided by a negative gives me a positive 1. Then we have that 4x plus 1, that's the common term. I write down 4x plus 1, and then I have left over a 2x minus 3 that's in front of each of those parentheses. Okay, let's look at two last examples. 2x to the third minus 6x squared plus x minus 3. Looking to what's common to the first two terms, I have common a 2x squared, leaves me an x, minus 2 goes into 6 3 times. And what's common to the last two terms? Well, there's nothing common to those two terms. 3 doesn't go into both of them, and they don't share an x. So remember what I said about that 1 being a special number. Well, in this case, we bring down the sign, and since we have to have some kind of common factor, we'll write a 1 down, because 1 does divide into everything. And 1 goes into x and leaves x, and 1 goes into 3 and leaves 3. And since we have a positive here, it doesn't change any signs. And notice, for it to be factorable, they have to match. In this case, they do, x minus 3. And I don't know that I've said that out loud as we went through this, but if those things here, these factors here, do not match, then this problem is either done incorrectly or it is not factorable. So you want to either go back and attempt it again, or if you've attempted it more than once and it still comes out as not the same, then the problem is not factorable. Okay, let's look at this example here. Now, I didn't really emphasize it in the other problems because I wanted to get to the part that you really needed to look at. But in this one right here, there is something that we need to do first, and that is to take out the greatest common factor. This problem has an x that's shared all the way through. Even though there's a 6 and a 3, there's not a 3 here. Even though there's a 2 here, there's not something divisible here and here, but there is an x that's common all the way through. So we do need to factor out that x before we do anything else. That has to be done first, because you always look for that greatest common factor. Then the common factor to the first two terms is the x squared. Leaves me 2x plus 1. Bring down that minus sign. The common factor to 6 and 3 would be 3. Remember that that's going to change that to a positive 2x. 3 goes into 6 2 times. A negative divided by a negative gives me a positive, and a negative divided by a negative gives me a positive 1. Then that 2x plus 1 and 2x plus 1 is the same. So we have 2x plus 1, x squared minus 3. And don't forget that common factor of x that we need to bring down to complete our problem. And this is factoring by grouping. If you have additional questions, be sure to come by and see me in room 222 of the Math and Behavioral Social Science.